Welcome to Chemistry Lab. Today's experiment, calorimetry. Most of this lab today is a giant heat lost equal heat gained homework problem where we heat up a metal and transfer the hot metal to room temperature water and watch the temperature change. From that, our goal is to calculate the specific heat capacity of the metal. If we think of this like a giant heat lost equal heat gained homework problem, looks like this. Heat lost is equal to heat gained. It's going to be the hot metal that will be losing heat, so I'll go ahead and write the word metal over here. And it'll be the room temperature water that will be gaining heat. After you pour hot metal into it, the room temperature water should warm up. If we use symbols, we'll use a negative sign to indicate heat being lost and a Q for heat. And I'll use a little M for metal. And it's equal to Q for water. And we know from the specific heat capacity equation, right, specific heat capacity is equal to heat divided by mass times change in temperature. And when we rearrange this equation to solve for heat, we have specific heat capacity times mass times change in temperature. So we can set that up for the metal, negative, specific heat capacity of the metal times the mass of the metal times the change in temperature of the metal is equal to the specific heat capacity of the water times the mass of the water times the temperature change of the water. We are going to be able to measure everything in this equation except for the specific heat capacity of the metal, which we can determine from here. The specific heat capacity of the metal, let me change out here with my pen. Specific heat capacity of the metal is going to equal the specific heat capacity of water times the mass of water times the delta T of water divided by the negative mass of the metal times the delta T of the metal. So specific heat capacity of water we know is 4.18 joules per gram Celsius or joules per gram Kelvin. The mass of the water we're going to know because we're weighing it out. I'll look at the temperature change here in a minute. The mass of the metal we're going to know because we weigh that out too. And let's also look at the change in temperature for the metal. Change in temperature is always final minus initial. So if we look at change in temperature of water, it's final minus initial. The initial temperature of water is that room temperature. You're going to measure it with a temperature probe in lab, but it's whatever that room temperature is. You don't want to get the water mixed up in this experiment because you are using a hot water bath to heat up the metal. That's how we're going to get the hot metal. So you're not looking at the temperature of the boiling water bath. You're looking at the temperature. The water in the experiment is the room temperature water. So you've got the initial temperature of that. The final temperature is the temperature that you get after the metal is added to the water. So the difference between those is delta T of water. The delta T of metal is also final minus initial. In this case, the initial temperature of the metal is 100 degrees Celsius because that's the boiling point of water. And we've got a boiling water bath that we are using to prepare that hot metal with. So you're not measuring the temperature of the boiling water bath because if you did that, you would have to wait for it to cool back down and it might mess up your experiment because now the temperature probe itself would be hot. So we're just going to assume that the initial temperature of the metal is 100 degrees Celsius, same as boiling water. The final temperature is the same for the whole system. This number is the same for both because that's the temperature you get after you mix the two together. Notice in the case of delta T of the metal, this is going to give us a negative number, right, because the metal cools down. But that's okay, there's a negative sign here. Those negatives will cancel out and you don't have to worry about them. To give you an idea of what this looks like, the metal pellets that you're using are small pellets that will be in a small beaker when you first pick them up, and you can weigh them out on the balance in that beaker, and then you'll want to use the large test tube that you find at the front of the lab to put all of the metal pellets in that large test tube. Then you want to have a setup with a clamp in your hot water bath. That clamp will hold the test tube in place in the hot water bath, and you could also use the clamp as a holder whenever you remove the test tube from the hot water bath and then pour the metal into the cup that contains the room temperature water. Or you could use the test tube holders that are in your lab drawer. After that, you'll want to set up the LabQuest probe with the temperature probe. Be sure to select the program that's on the SD card. If you don't see the little SD symbol on your LabQuest probe, let one of the assistants know. Sometimes the card isn't seated properly or just something needs to be done about that. But make sure you get the experiment off of the SD card when you do that. In Part B of the lab, this is all Part A. Part B is much simpler. You're not heating up anything in Part B. What you're doing is looking at the heat of solution for an ionic compound. So you're going to have a weighed out amount of water, and you're going to weigh a certain amount of a solid compound and then put that in the water and dissolve it. The process of dissolving a solid may be exothermic or endothermic. You'll measure the temperature either going up or down when that happens, and you should be able to measure what we call a heat of solution, which would be in joules per gram. In a sense, you're only looking at one side of this equation. You know the specific heat capacity of water, you know the mass of water, and you know the temperature change that you measure. That is the value of Q, right? And you're going to, which we would be in joules. That's joules. Divide that by the number of grams of solid that you weighed out, and that would be the heat of solution for this compound. If the temperature goes up whenever you dissolve the solid, you are releasing heat to the environment. Remember that temperature probe is part of the environment. So if the temperature goes up, that is heat released, and we would say that's exothermic. If the temperature goes down instead, that means that heat is leaving the environment, your temperature probe as being part of the environment. The heat is leaving the environment and going into the system, and that is therefore endothermic instead. Have a great lab.